Hello and welcome back to my channel, my dear friends. In this part 3 of dynamic programming, we will discuss that how to perform tabulation, what exactly is tabulation and its benefits, and with the table for 0 and knapsack. Along with that, I'll also solve the problem for you. So, let's begin without any waste of time. In the last part, we have seen that 0 1 knapsack is a choice based question which you have to use recursion and DP to extract all possible solutions and then store the solutions in the DP array. But, however, there is even a better way than memorization to solve it. And what is that better way? This is tabulation, which I have taught you in the earlier parts. What exactly is tabulation? But today I'm going to teach you to how to perform it. So tabulation is like a brother of memoization. Tabulation is like a brother to memoization. Memoization is what we have done in this question. So we have used recursion, and then we have like fed all the solutions which we are taking into the DP array, and then we are checking if that solution is already present in the DP array, and if it is there in the DP array, then we are returning that without calculating a new solution to the same problem we have calculated before. However, in tabulation, what we do in memoization, we break the the main problem into sub problems, into smaller parts. However, in tabulation, what we do is we start from the base condition. So we start from the base condition and build our way to the top. This is what we do in tabulation. So tabulation, the benefit of tabulation is that it does not use the overhead for recursive stack space that we are using. That is, when the recursions are called, this helper function is called again and again, then what happens is it feeds itself in a stack memory, which is a basic type of memory in like the programming. So it is calling itself again and again, and it is using the stack space, which is equal to the number of calls in recursion, which are a lot if you consider this value. And then it also uses some extra time to like sort out that stack, and this is known as overhead time. However, in tabulation, we do not use recursion. That is the main part. We use only iteration. We use iteration and we solve it using iteration. And how do we solve it using iteration? I'll tell you here. So what happens exactly is there is always a table in tabulation. If you have to understand tabulation, you have to build this table always. I guarantee it, you will only learn tabulation if you build this table like this. So the parameters of this table are capacity. The input is this. This is W is the capacity. The capacity of a bag in 0 1 knapsack. This is capacity 4. And then we have profit array and we have corresponding weight array. So the one of the main parts of tabulation is deciding what to keep as parameters. So I have kept this parameter, this horizontal parameter, as the capacity of the bag. And I have also taken 0 because it is a base condition, and I will explain it to you later. But the main conditions are 1 2 3 and 4. So I have taken the capacity 4. This is the maximum capacity, and I go till the maximum capacity. And this is our pointer I. This is our pointer I. I pointer is the pointer we are using to traverse the weight array in this question. So we are using this pointer I. We are using it to traverse the weight array. That is I plus 1, which is here, then I plus 2, which is here. So we are using I to discuss like the weights. The weights, and we are using it to traverse the weights. So in tabulation, how do you know that we have to keep these capacity and this pointer I as parameter? In the last part, I have already told you that when we use DP array, what we store in this DP array is the changing variables in the recursion. So if you have not yet watched the last part, please go watch it. And if you even don't, you will understand what I'm telling right now. So this is the variable W, that is the capacity. So whenever we select an item from the array, for example, if we select this item, the capacity changes. So if this item is kept here, the capacity goes 4 minus 4 equal to 0. So this is a change that occurs in capacity. So the capacity is always changing. and whatever element is changing, like here it is changing. However, in these two conditions we are not using a weight, is we are not putting the weight. So in these conditions the weight does not change, but it changes here. Whenever we are putting an element into the bag, the weight or the capacity changes. So we will use this capacity. You can use it either as the vertical parameter or the horizontal parameter. It does not really matter. So I have decided to use this capacity as the horizontal parameter, and this capacity is constantly changing. That's why I have selected it as a parameter. So I'll give you guys 5 seconds to judge whatever is the next thing that I have to keep as parameter. Of course, it is I, which I have already mentioned. But why is it I? So the answer is it is I because the I is always changing. The I is changing. We're using I to traverse the array. So if we select an item or we skip an item, in both conditions we always increment I plus 1, because we have to go to the next element. If we do not go to the next element, then this problem will be forever stuck in a loop, and the question will go nowhere. So I is our second parameter, which is constantly changing. And if I is changing, we are keeping it as a parameter. So now what exactly do we have to fill in this array, in this particular array? So let us discuss. What we will do is, if our capacity over here is 0, let's think about this row first, this single row. Then we'll talk about other rows. If we consider the capacity to be 0, okay, if the capacity is 0, we have not gone to 1, we have not gone to 2, we are here at the beginning, we are at the 0. So I want you guys to think, if the capacity of this bag is 0, will there be anything that we can put in this bag? So I don't think so. There will be nothing that we can put in this bag. So in all conditions in this row, there will be a 0 present. There will be a 0 present. All right. So the second thing is, let's discuss about this row now. This row, the all these zeros are the base condition, because as you can see here, I have put in this question as well, if weight equal to 0, then you have to return 0, because we cannot put anything. So this is the base condition, this over here is the base condition. That's why we use this base condition in the tabulation as well, because I have told you earlier that we derive the answer from the base equation. We do not break the larger problem into the smaller parts. We use the smaller parts to solve them into a larger problem. So then we'll consider this row, this I equal to 0. So I have kept here that 0, 1, 2 and 3, but there are only 3 elements, so this will be 0, 1, 2. So this must be confusing, but however, we are keeping 0 over here and we are starting from 1, because I have to always care about the base equation, base condition, because there is a base condition that I is greater than equal to weight dot length. So we are considering it to be smaller than weight dot length, and we are beginning the weight dot length from index 1. So it can be a little bit confusing, but trust me, over here we are going to fill these zeros as well, because this will be a base condition as well. All right. So again, let's try to move forward with this question. So when we are at I equal to 1, so we can see we're at I equal to 1. That is, we are at 4. Weight is 4. However, the capacity is 1. Capacity is 1. But the weight is 4. Because we are at the first index. So the first index says weight equal to 4. However, the capacity in this row, in this particular row is 1. So can we fit this element in this capacity? No, we cannot, because the weight is greater than the capacity. And here I have written, if the weight is greater than capacity, then increment I and do nothing. We have to do nothing, just have to increment I. So however, in this condition, we are going to fill this row first, so we will not increment I right now. Then for 4, is the capacity 2, right? No, I don't think so, because again the capacity is less than the weight. Then we'll put 0 over here as well. Then for the capacity 3, we'll put the 0 over here as well. But for capacity 4, let's see. The pointer is at 4 and the capacity is at 4 as well. So can we put here 1 because the profit is 1? These zeros are the profits. You have to know these zeros are the profits. This all everything I'm filling in this table is profit. I is traversing on the weight array. Weight is corresponding to the capacity. So we only have to judge if we can put here 4. Can we? Yes, we can. So if we put 4 in this capacity, then the profit becomes 1. Alright? Because the profit over here is 1 and 0 plus 1 equal to 1. So what we were saying is that if our capacity is 4 and we are at this pointer, so we can actually fill this with the 4 weight item, and which gives us a profit of 1. So we will add 1 to this number, the horizontally backward number, because this is a condition in tabulation. Whenever we meet a criteria, that is 1 and 4, we meet a criteria, we are keeping this. So we can use the horizontally backward one and add the profit to it to get this number. Then there is another condition that I'll explain it to you later. So when then we are coming to the second pointer. So we are over here 5. So when we are moving to the second pointer, that means I am not only considering this 5, I am considering this 5 and anything we have already left behind it. Alright, I am considering this 5 and anything that I've already left behind it. So I am considering this 5 and this 4 as well. So whenever the weight is, so then again let's consider this, our capacity is 1. We can neither fill 4 nor 5 because both their weights are greater than the capacity. So we will select whatever is greater, either this or this. Alright, we'll select either this or this, the backward one vertically and the backward one horizontally. And among them, whichever is the greater, then we will select it here. Again, let's come here. So again the capacity is 2, weights are 4 and 5, the capacity is smaller than the weights, then again we'll consider this and this, and whatever is greater, so both are same, so 0. Then again we'll come to capacity 3, and here and 0. Then we'll come here, so we'll consider because only we can put the weight 4 in the bag because the capacity is 4 again. Then this twist comes, if we can put 4, then the profit of 1 occurs. So to prove my point that we have to select either element from the, so we have selected this because this is also 1 and this is 0, so greater out of 0 and 1 is 1, so I have selected this again. So then the pointer is increased. Now we are considering all the three elements, all the elements in the array, that is the elements, this one and everything behind it as well. So when we consider this one, the capacity is also 1, so we can keep this one in this bag. Yes, we can. So we'll keep this here. That is this plus the profit that this gives, that is 3. Then we'll consider whatever is greater out of these two, 3, because there is nothing we can keep anymore, right? Then we'll consider whatever is greater 3 or 0, then 3. Then we'll consider whatever is greater 1 or 3, then 3, because we cannot keep 4 again because we have already kept 1. So we have to consider if it is greater than 3, then we should keep 4. But if it is not greater than 3, because we are considering here, this gives us the profit of keeping the item of weight 4. We are already considering keeping this item against this item, but this item gives us a greater profit, that because that's why it wins, and we keep this in this bag. So this final block will be our answer. The 3 will be our answer. Why? Because this is the final block. That means we have tried and tested all the possible all the possible combinations. So we have tested all these combinations, keeping all of these combinations, then we have compared each other. We are comparing this and this, then we have compared each other to get this answer. All right, so this is what exactly is tabulation. And if you can see, this is a matrix. This matrix can be of course represented by a 2D array. So if we consider a 2D array over here, that is dp of what? The first parameter is, this is capacity, and the second parameter is, that is I. If we consider this both plus 1, because we are, if the capacity is 4, then we have 1 2 3 and 4 5 columns. Here we have 3 columns, that's why we are doing plus 1 capacities in this dp array. Then what we will do is we'll take a for loop, and what we'll do is we'll fill the dp of 0. All right, we'll fill the dp of 0 I equal to 0. Why? Because we have used this base condition where capacity is 0, we have to fill 0 everywhere. So we are doing the same, and we'll do the same for I equal to 0. Why? Because if I equal to 0, then we are putting zeros, and when capacity equal to 0, we are putting zeros as well. So we are going to use this to put capacity equal to capacity and I is equal to 0, then we'll put 0. So this completes the base condition of our question. And then if I teach you what exactly, how do we write the code for this, I'll write the code at lead code, but I'm just telling it to you. So if we consider this and this, we have already done this base condition. So we have already done this base condition. So what do we have to do exactly after this? We have to start this traversal from this matrix. This matrix, we have to start this traversal because these are already filled. This is the base condition. So we have to start the traversal from this part. All right. So we'll start from for I equal to 1 and plus plus until the it is less than the weight of the array or the capacity. Then j equal to, however we have already kept I as this parameter, so I should name it to something else. I should name it to a. Then j equal to 1, then j plus plus until j is less than I. All right, or j is less than n, that is the number of items, less than equal to n. Then what we will do is we will consider if the current item we are on, if weight I is greater than the current capacity we are on, j. All right, if it is greater than the current capacity we are on, then we'll consider putting it. And if we consider putting it, we will consider doing a plus of that profit to the previous the diagonally previous element. So how do we access this diagonally previous element? We do dp of I, oh sorry, a minus 1 and j minus 1. We do this. If we are on dp of a and j, we do both minus 1 to access the diagonally previous element. And then we will add the profit from the profit array where the pointer will be j, that is. And we will get the answer as 3. For example, over here as 3, because I have added 0 plus the profit of j is equal to 3. So that's how we will complete this tabulation. And the tabulation part is sincerely very better than the memoization part. And I will show it to you using the results from both the tabulation part and the memoization part as well, because we have to consider both of them and their space and time complexities. Whichever is better shall be the better answer to a particular problem. And according to me, and according to of course everyone else, tabulation is better because it minimizes the overhead charge and even the recursive stack space. So let's continue to lead code. So I have already explained this problem, and we are going to explore the tabulation solution which I have discussed in this whiteboard. Here it is. This is the solution. This is the table. So as we can assume that we are always filling zeros at the base conditions, that this is something I have explained to you. So when we are making out this base equation, we have to keep one thing in mind, that I is 0. whenever I is 0, then we have to completely fill this with 0, and whenever the capacity is 0, then we have to fill this row with 0 as well. So let's start with creating a dp array. So the DP array will be created like similar to what we have created in this coding question when we have used memoization. So we have created the DP array with w plus 1. W here stands for capacity, and weight dot length my plus 1 stands here for the length of weight array or profit array, as they are both same in length, plus 1. That is, this is going to be our pointer. This is going to be our pointer. This is going to be our pointer, which is I in this case. I is the pointer, and this the second parameter in this 2D array will be our pointer. Then what we will do is we'll fill the DP array with zeros, like we have filled it over here with zeros, these zeros. Then we will start traversing the complete array. So let's start coding this. First of all, we have to declare a DP array. 2D DP array is equal to new int. This is going to be the, sorry, this is going to be w plus 1 in length and weight dot length plus 1. All right. So this is going to be our DP array. Then what we will do is we will traverse the complete array. We'll use two loops, int I equal to 0, I is less than the first parameter. This is our pointer for the first parameter. So I will be our current capacity in this question. So we'll use w plus 1 I plus plus. Then the second array will be used for our pointer variable, that is the amount of items we are able to access at a particular position. So this will be our second pointer, weight dot length plus 1 and j plus plus. All right. So according to the base condition that we have discussed, what happens is we put an if condition here, and either of these two, if I is 0, the pointer is 0, or the capacity is 0. In both conditions, we are completely filling the array with zeros. So we'll put the condition if I equal to 0 or j equal to 0. Then dp of I j equal to 0. We'll put 0. All right. So this is our first condition. Then if they are not 0, else if, let us consider this statement. So if they are not 0, then we are like standing over here. All right, we are standing over here. So what we will do is, if the weight is the current weight we are standing on, that is I. If our I is greater than, or if I is less than or equal to, that is the capacity is less than or equal to weight array of j minus 1, because this is our pointer to the weight array. So this statement over here says that I is our current capacity, and our current capacity is less than or equal to, that is our current capacity is greater than or equal to should be there. So if our current capacity is greater than or equal to the current weight of the element, then we actually can insert the element. That is a fact. So if the capacity, for example, the capacity is 4 and the element is 3, or it is 4, then we can insert the element. So we have to check a condition that if it is going to benefit. So in this case, we can either put the element or not put the element. We have to explore both choices, like we did in recursion, but there is a different way to do it in tabular form. So what will happen is we will add the value of j minus 1, that is the current item we are standing on, plus dp of I minus weight of j minus 1. This is the first condition, and the j minus 1. This is the second parameter. So what we are doing over here is that if we can we can put an element, then we are going to calculate the maximum. Let me write the second condition as well first. So dp of um, I minus 1, dp of I comma j minus 1. This will be our second condition. So what is happening here is that if we are considering the element, if we are considering the element, then we are adding its value, and we are also reducing its weight from the current capacity. So if you keep an element, if you have the current capacity of 4 and if you select an element of 2, then the new capacity will be 4 minus 2 equal to 2. So that's what we are doing here. And this is our second pointer, which is the pointer to the item. It will always be the same. Then here we are not changing anything, so it will all be the same as well. Then else that means we cannot select the item. So if we cannot select the item, we'll only consider I and j is equals to math dot maximum out of dp of I minus 1 j and dp of I j minus 1. So this is going to be what I have already explained it to you over here. So if we cannot keep an element, then I have explained it to you. For example, if we cannot keep an element, then we have to check if this element is greater or this element is greater, like this element or this element, and the greater out of both of them will be used over here in the new chamber of the table. This will be our new element. So what we are doing here in this equation is we are only considering this element and considering the maximum out of it and then storing it in the value of IJD. So I already have told you that the final answer will be here. So the final column of this array will be, wait, this is the right. So we have to return the final column of this array, which will be w and which will be weight dot length. So this will be the final element. Then we'll compile and run. Let's see what happens. So my output and the expected output is same. Let's submit this question. Let's see. So all the test cases are passed and this question is completed via tabulation. So thank you, and if you understood tabulation, please like the video and stay put for the next part. And in the next part, I'll explain the subset sum problem, which is also another very important problem that you might encounter in many papers or interviews or something else.